Hello Year 12 and welcome to the fourth and I think final video for this unit on ratios. We're looking at scales on maps today. I don't mean that I've caught a fish and I've cleaned it and made a mess. No, that's so funny. No. We're talking about the scale. We're talking about sort of how shrunk down things are on that map, right? Because you can't have a map that's the same size as the thing you're trying to display. That would be pointless. No. Scales on maps, we write them as a ratio, and typically it's 1 to number 1 and then my colon to indicate a ratio, some number. Right? Essentially that means is take something on the map, multiply it by that number, that's how big it will be on the ground. Alternatively, find something on the ground, divide the length of it by this number here, and that's how big it'll appear on the map. Rightio. Now, here we go. Let's have a look at an example here. Map has a scale of 1 to 250,000. Right? 1 to 250,000 scale map. That's going to show you like about half of the Hunter Valley in one go, I reckon. Map that sort of scale. Not quite that much. No, Newcastle to Maitland maybe. Anyway, what is the actual size of 1 centimetre on this map? Well, remember, we take my 1 centimetre, take the thing on the map, multiply it by that number, because it's going to be much bigger than 1 centimetre, right? So I'm going to say 1 centimetre times 250,000 equals 250,000 centimetres. But really, how big is 250,000 centimetres? Remember, there are 100 centimetres in a metre, so we can divide that number by 100 and I get 2,500 metres, and there are 1,000 metres in a kilometre, so that's 2.5 kilometres. Oh no, our half the hunter sounds reasonable now, actually, on reflection. Now, we have another example. Let's just go over this one though. How did we work out, right? If I measure something that's 1 centimetre long on my map, I multiply it by this number. But I get my answer in centimetres, because that's what we started with. So I've got to convert that to a reasonable unit, which is probably kilometres. Now here we go. A scale of 1 to 1,250. How long will a 50 metre swimming pool appear? Now, it's going to be less than 50 metres, right? It's going to be quite a lot smaller than that. I need to divide this number by this number, right? My actual size divided by my scale there. So I need 50 metres divided by 1,250. Now, it's going to be easier if I do this. You ready? 50 metres will be 5,000 centimetres, because I multiply it by 100 divided by 1,250. Right, that's a bit easier, and that gives me 4 centimetres. So it will be 4 centimetres long. Rightio? 4 centimetres long. So to convert the actual size to an image size, we divide by the scale, but you have to use consistent units. Rightio. One more thing here to calculate the scale. Maybe what I actually have here is maybe a photo like we're going to see below, and I want to know what scale the photo is. Right. Ideally what we're going to do is we find something in the photo that we recognise, and we calculate the scale. We divide the actual measurement by the image size. Actual size divided by image size. See how it works. Let's say I've got a photo that I took from a drone pointing straight down. I can see the goalposts on a football field and they look like they're 28 millimetres apart. What's the scale? Well, the goalposts on a football field should be how far apart? 100 metres. So my scale is 100 metres, or 100,000 millimetres, right? So 100,000 divided by 28, right? Millimetres divided by millimetres. I'm going to need my calculator here. Here we go. 100,000 divided by 28 equals 3,571. Therefore, the scale is 1 to 3,571, approximately. Rightio. Now, we're going to do a bit of an exercise here in class. I'll just talk you through it a little bit as a bit of an introduction. Here is a photograph. You'll see that on your notes. What is that a photograph of? I hope you can work out that is a photograph of your schools, of my school, of St Mary's at Maitland. Right, we don't quite have all the detail in, but right now I imagine that we are, where are we? We must be right about here. Yeah, that's where we are, somewhere there. We're sitting around here. It's a bit pointless me trying to do this on here because it's displaying at a different size on my screen, which affects the scale. But we are going to measure something on that photo of which we know the length. Right? There'll be a surprise in this. Okay, we're going to do that, and we're going to then use that scale to maybe calculate the size of some other things on that photo without actually going out and physically measuring them. We'll just measure one thing so we can calculate the scale, and after that we can do calculations directly from the photograph. Okay, hope you enjoyed it. I hope it made sense. I will talk to you in class.